Hello class, and welcome to the second day of section 4.4. Today's lesson will be covering perpendicular lines through a given point. When we're talking about perpendicular lines, we're talking about lines that intersect at a right angle and have opposite reciprocal slopes. So notice these two lines run into each other at a 90-degree angle. When we're talking about opposites, we mean positive and negative. So one slope is going to be positive and one is going to be negative. When we're talking about reciprocal, that means the fractions have been flipped over. So if we're looking at this example here, our first line starts at 3, goes up 1 and over 2. And if we're looking at our second line, we're starting at -2 and going down 2 over 1. Notice with the slopes, the first slope is 1/2 and the second one is -2 over 1. So we have a positive and a negative, and we have the numbers have been flipped over. So the first thing we're going to practice is just finding perpendicular slopes. So if I start with a negative slope, my second slope is going to be positive, and then I have to flip these over. So I'm going to turn it into a positive 11 over 6. With this next one here, I start with a positive slope. So I'm going to go ahead and when I flip it over, I'm going to make it negative. So I'm going to make it a -5 over 2. Negative, positive, positive, negative. Both of the numbers have been flipped over. When I start with a slope that is a whole number, I'm going to go ahead and turn it into a fraction first. So -4 turns into 4 over 1. Then again, I need to flip my slopes, my points, and I'm going to turn it into 1 over 4 and make it positive. With this final example, we start as a positive 1 over 7. So when I flip it over, I'm going to make it a negative, or you can just write this as a -7 when it simplifies. So notice, in each case, one slope is positive and one is negative, and the numbers have been flipped over or reversed. Go ahead and try to find these two perpendicular slopes on your own. The first one started with a negative, so it turns to positive. When we flip it over, it's 9 over 4. Second one started as a positive, so when we flip it over, it's going to become a -1 over 8. Now to actually find perpendicular lines. So we're going to look to write an equation of a line in slope-intercept form. Again, remembering that's y equals mx plus b. That passes through the point -64, 5 and is perpendicular to the line y equals 8x minus 26. So our first step again is going to be to find the slope. We're only caring about the slope. Our original slope is 8. In order to find the perpendicular slope, we need to flip it over and we're going to make it negative. So I've got a positive and my perpendicular slope is negative. This is the slope I am going to use for my line. Not this original slope. If I use this, I'd be finding a parallel line. I need to find my perpendicular line. Again, just like the parallel lines, we have our two options. Our first option is to use our point slope format. So I've got y minus 5 is equal to -1/8 times x minus -64 minus negative turning into positive. Then I go ahead and distribute, and I get y minus 5 is equal to -1/8 x minus 64 times 1 is 64 divided by 8 gives me -8. Then I need to isolate my y, so I'm going to add 5 to both sides, giving me a final answer of y is equal to -1/8 x minus 3. Using the solving for b method, I'm going to start by saying 5 is equal to -1/8 times -64 plus b. When I do that multiplication, I'm going to get 5 is equal to 8 plus b. To solve for b, I'm going to go ahead and subtract 8 from both sides, giving me -3 is equal to b. So my final equation then becomes y equals -1/8 x minus 3. So again, in either case, we end up with that same equation. Perpendicular to that original because I had a starting slope of 8 and a final slope of negative 1/8. Go ahead and try this one on your own. So when we find that perpendicular slope, we flip it over and make it positive, so we get 1/7. Plugging it in either to the point slope form or to the slope-intercept format, we're going to end up with the equation y equals 1/7 x minus 4. Now we're going to talk about what happens if we start with a fraction slope. So again, we only care about our slope from this original equation, so our starting slope is negative 2/3. When I make it perpendicular, I'm going to flip it over and make it positive in this case because we started with a negative. In order to solve the problem, if I plug it into my point slope format, I'm going to start with y minus negative 4 is equal to 3/2 times x minus 6. Minus a negative turns into a positive. Distributing, I end up with y plus 4 is equal to 3/2 x minus, we got 3/2 times 6/1. 3 times 6 is 18. 2 times 1 is 2. 18 divided by 2 gives us 9. Then we're going to need to solve by subtracting 4 from both sides. And we end up with our final equation of y is equal to 3/2x minus 13. If I go ahead and plug in to my slope-intercept format, I'm going to start with negative 4 is equal to 3/2 times 6/1 plus b. After I do my multiplication, I end up with negative 4 is equal to 18/2, which gives me 9 plus b. Going ahead and subtracting 9 from both sides, I'm going to end up with negative 13 is equal to b, giving me, again, a final answer of y is equal to negative 3/2 x minus 13. So again, we end up with the same equation, no matter which format we use, and we see that our slope, if I write it correctly, is 3/2x, which is the opposite of negative 2/3 x. Go ahead and try this one on your own. Looking at the perpendicular slope, you're going to pick it out, which is negative 4/3. Plugging in either to the point slope format or the y-intercept format, you're going to get an answer of y is equal to negative 4/3 x plus 19. If you have any questions about this or anything else from the lesson, please let me know.